Hey everyone, and welcome to today's Explainer. I am super excited about this one because, honestly, we're tackling something that's going to totally change how you interact with AI in your dev environment. Today, we're taking ultimate deterministic control over Claude Code. We're diving into a feature called hooks. If you've ever just wanted to lay down the law in your coding workflows, making sure certain things happen every single time without fail, well, you're in exactly the right place.
So here's our roadmap for today. We're going to cover prompts versus deterministic hooks, configuring your project-level settings file, a step-by-step for auto-formatting, how to block dangerous code operations, and finally, automating task notifications.
All right, let's jump straight into Section 1, Prompts versus Deterministic Hooks.
Let's set the stage with a pain point I know we've all felt. You write out this absolutely beautiful set of instructions in your Claude.md file, right? You tell Claude, hey, run prettier after every single file edit. And most of the time, it listens. It does exactly what you asked. But then, out of nowhere, it just kind of doesn't. It skips a step, and suddenly you're left doing manual cleanup. So why does it do that? Well, it all comes down to how standard prompting actually works.
You see, the big takeaway here is understanding the difference between the two approaches. Prompts, they're basically just suggestions. Even the most aggressive system prompts are still just instructions for an AI to interpret. And where there's interpretation, there's wiggle room. But hooks, oh man, hooks are guarantees. A hook forces an action to happen every single time, absolutely no exceptions. You aren't politely asking the AI to remember something, you're building a hard rule right into the environment.
Which brings us to the actual definition. Hooks are commands that always run deterministically at specific points in Claude Code's lifecycle. That word deterministic is the absolute key here. When a specific event triggers in the system, your command runs. Period. No AI can get involved. It's literally how we take absolute control back.
Moving on to Section 2, the project-level settings file.
Now that we know what these things are, let's talk about where they live. Hooks are set up right in your settings.json file, or you can drop them in a .hooks folder. The setup is really straightforward. You just need three things. First, pick your lifecycle event. Second, and this is optional, set a matcher, which tells the system exactly which tools the hook applies to. And third, drop in the actual command you want to run. The best part? Because this lives in your project-level settings.json, you check it straight into your repo. Your whole engineering team gets these exact same rules the second they pull the code.
And you get an insane amount of granularity here. Look at these lifecycle events. You've got user prompt submit, which fires right when you hit enter, way before Claude even sees your prompt. Then there's pre-tool use and post-tool use to basically wrap Claude's actions. There's a notification event, and finally a stop event for when Claude is totally done responding. You can inject your own scripts into literally any of these moments. Oh, and before we look at specific examples, here's a massive pro tip straight from the source docs. When writing commands for your hooks, use the Claude_project dir environment variable. It lets you reference scripts stored inside your project perfectly. Using this guarantees your team scripts are going to work flawlessly, no matter what random directory Claude happens to be working from on a developer's local machine. Okay, Section 3, Step-by-Step Auto-Formatting. This is for sure the most requested use case. Let's make sure our code formatting literally never gets skipped again. Here's the step-by-step. First, open up that settings.json file. Second, set the event to post-tool use, because obviously we want the formatter to run after Claude actually changes the file. Step 3 is super important. Add a matcher for edit or multi-edit. That makes sure the hook only fires when code is actually changed, not when Claude is just reading it. Finally, write your command to check the file extension and run the right formatter. Prettier for TypeScript, Go format for Go, Rough for Python, whatever you use, this hook guarantees it runs every time Claude touches a file. Problem solved. On to Section 4, Blocking Dangerous Code Operations.
So auto-formatting is amazing for keeping things clean, but what about keeping things safe? Let's look at hooks as basically an unbreachable security checkpoint. Remember that pre-tool use event? This is your security holy grail. When a pre-tool use hook fires, it intercepts the tool call right before it executes. Your script literally receives the tool name and the exact input data, formatted as JSON right on standard input. That means you can programmatically inspect exactly what Claude is trying to do before it's actually allowed to do it.
And here is the magic number you've got to remember. 2. If your hook script looks at Claude's planned action and says, nope, that violates our rules, it just exits with code 2. Boom, action instantly blocked. On the flip side, an exit code of 0 means all good, go ahead. This is exactly how you enforce hard rules, like blocking writes to a production config folder, or stopping any bash command that tries to sneak in an rm-rf.
Honestly, this is why the system is so incredibly robust. When you block something with that exit code of 2, it doesn't just silently die. Any standard error messages from your script feed straight back into Claude's feedback loop. Claude actually sees your error message, knows exactly why it got blocked, and can instantly adjust its behavior to try a safer approach. It's literally a self-correcting safety net. How cool is that?
All right, our last section, Section 5, Automating Task Notifications.
For this final tutorial bit, let's talk about a huge quality of life upgrade. Say you've given Claude this massive, totally time-consuming refactoring task. You definitely don't want to just sit there staring at your terminal forever, right? Well, you can set up a hook targeting the stop event. Like we covered earlier, this event triggers the exact millisecond Claude finishes its task. Tie that event to a command that plays a sound, pops up a system alert, or even pings your Slack channel. It's the ultimate way to track your workflow, so you know instantly when a long-running job is completely done.
As we wrap up this explainer, I really want to leave you with this golden rule straight from the source material. If something needs to happen every time without fail, don't put it in a prompt, put it in a hook. That one sentence captures the entire philosophy here. Use prompts for the creative stuff, the logic, the guidance. But for guarantees, for safety compliance, for strict formatting, you build a hook. Every time.
By setting up your settings.json, tapping into those lifecycle events, and committing those rules to your repo, your whole team gets to operate with total deterministic precision. So look at your own codebase right now. What manual chore, what safety check, or what notification are you going to automate next? Jump into your project, set up your very first hook, and feel that level of absolute control for yourself. Thanks so much for joining me on this explainer, and happy coding.